Think about the last time you used your banking app. You tap the screen, check your balance, and it just works, right? Instant. But that one simple tap, well, it's just the tiny tip of a massive, invisible iceberg. Underneath the surface, there's a huge fortress of technology working around the clock, and it has one job, and one job only, to keep your money safe. So today, we're going to take a tour of that digital fortress.
So here's the plan. We'll start with the blueprint, the actual architectural plans for this whole thing. Then, we'll go check out how they guard the outer gates. From there, we'll venture deep inside to explore all the different secure zones. After that, we'll dig down into the physical foundation it's all built on. And finally, we'll look at the ultimate what-if plan for when things go really, really wrong.
All right, first up, the blueprint for security. You see, before you even plug in a single server or write one line of code, there's a set of core principles, almost like a constitution, that guides every single decision. These are the absolute non-negotiables for building a financial fortress today.
So when we talk about this invisible fortress, what are we really talking about? What does it actually look like behind the scenes? Because it's so much more than just having a strong password. It's a complete philosophy, a whole mindset, and it all kicks off with one really powerful idea.
And that core idea is called defense in depth. Seriously, the best way to think about it is like a medieval castle. A castle doesn't just have one big wall, right? It's got a moat, then an outer wall, then an inner wall, plus watchtowers and guards at every single gate. If an attacker somehow gets past the moat, well, they still have to deal with the wall. That is exactly how bank security is designed. It's just layers on top of layers of protection.
And defense in depth is just the beginning. That whole philosophy is propped up by these other core principles. Take zero trust architecture, for example. That basically means you trust nothing by default. Every single person, every device, every connection has to prove who they are, every single time. Or segregation of duties, which just makes sure no one person has the keys to the entire kingdom. All these principles together, they form the unbreakable laws of this build.
Okay, so with that blueprint in our heads, let's start our tour, where the action is, the outer walls. This is Section 2, guarding the gates. This is the edge, the perimeter, where the bank's secure private network has to meet the wild, unpredictable world of the open internet.
And the very first thing all that internet traffic hits are the edge routers. Think of these as the main gateways, the front doors for everything coming in and out. Now, key design here is redundancy. These gateways are always hooked up to at least two totally different internet service providers. So if one of those ISPs has an outage, traffic just seamlessly flips over to the other one. The front door can never, ever be closed.
And right here at the entrance, you get a perfect picture of defense in depth. First, special DDoS protection services act like a giant filter, just dropping huge floods of junk traffic designed to crash the system. Then, whatever gets through that filter is closely inspected by next-generation firewalls. And behind them, intrusion detection systems are watching everything, like a million security cameras looking for any suspicious behavior and ready to sound the alarm instantly.
Okay, so we've made it past the outer gates. But once you're inside, it's not just one big open courtyard. And that brings us to Section 3, inside the secure zones. The inside of this fortress is actually chopped up into multiple, highly controlled and totally separate areas. And this is that whole segregation principle in action. Each zone has a very specific job and incredibly strict rules about who or what can even get in. You've got the DMZ, which is for public stuff, like the website. Then there's the application zone, where the core banking magic happens. Deeper in, you have the database zone. That's where the crown jewels, all your data, are kept. And finally, the management zone. That's where the watchtowers are. Let's talk about that first zone for a second, the DMZ, which stands for Demilitarized Zone. The best way to think of this is as a buffer area, a controlled no man's land. The bank's public website, the mobile app gateways, they all live here. They're allowed to talk to the internet, sure, but they are completely and utterly walled off from the critical systems inside. It's designed to take the first punch. Now, once you get past that DMZ buffer, you're getting into the highest security areas. And this quote says it all, really. The application and database zones, they're the digital main vault. Plain and simple. The rules here are strict. Every single bit of access is controlled, it's logged, and it's restricted to only what is absolutely necessary. Basically, nothing and no one gets in here without a very, very good reason.
So who's up in those watchtowers, keeping an eye on everything 24/7? Well, it's actually two different teams. You've got the Security Operations Center, the SOC. These are your cybersecurity defenders, actively hunting for bad guys and responding to threats. And then you have the Network Operations Center, the NOC.
They're the system engineers, making sure everything's running smoothly and the lights stay on. One team hunts for enemies, the other keeps the fortress running. Now, all this digital security, all these zones and firewalls, they don't just exist in the cloud. They have to run on real, powerful, physical hardware. So let's pull back the curtain on the unseen foundation. This is the actual concrete and steel that our digital fortress is built on.
So what are we talking about here? We're talking about racks and racks of high-performance servers running virtualization platforms to be super efficient. It's all connected with a blazing fast fiber optic backbone. But just as important is the physical security. You need a keycard to even get in the parking lot. Then you've got biometrics, 24/7 guards, and even things called man-traps, which are little rooms where a second door won't open until the first one is closed and verified your identity.
And inside these super secure data centers, there's a special network called a Storage Area Network, or SAN. You can think of this as a private, secure superhighway just for data. It only connects the servers to the storage systems where your data is actually kept. It has absolutely zero connection to the outside internet, which makes it incredibly fast and incredibly secure.
Of course, none of this works without power. So what happens if the whole city grid goes down? Boom, the failover is instant. First, massive batteries called an uninterruptible power supply take over so seamlessly there isn't even a flicker. Then, just seconds later, huge diesel generators automatically roar to life, and they can power the entire data center for days on end if they have to. The power always stays on.
But let's ask the really scary question. What if the worst of the worst happens? A massive fire, a flood, some regional disaster that takes out the entire data center. Well, that brings us to our final stop on the tour, the ultimate backup plan, otherwise known as disaster recovery.
See, banks don't just have one backup site, they have multiple. There's usually a near data center in the same city. That's for quick failovers to handle smaller problems or planned maintenance. But then there's the disaster recovery site, the DRS. This is the true lifeboat. It's located in a completely different part of the country, with its own power, its own networks. It's a mirror image of the main site, ready to take over if the first one is completely wiped out.
And the success of this whole disaster plan really boils down to two critical metrics, RPO and RTO. The recovery point objective, RPO, asks a simple question. How much data can we afford to lose? The recovery time objective, RTO, asks how quickly do we have to be back online? For a bank, the goal for both is as close to zero as is humanly and technologically possible. Zero data lost, near instant recovery.
And you know, this isn't just some plan sitting in a dusty binder on a shelf. Banks run regular, mandatory disaster recovery drills. We're talking about drills where they actually shut down the main site and fail everything over to the backup site just to prove that it works. They have to constantly test and practice so that if a real disaster ever strikes, the plan works perfectly without a hitch.
So you see, at the end of the day, security isn't just one thing. It's this whole system that has to work together. It's the network security at the gates, it's the physical security of the building itself, the security of the applications, the redundancy of all the data, and of course, that constant operational monitoring. Every single one of these pieces has to be perfect for the whole shield to work.
So what are the big things to take away from our tour today? First, security is always built in layers. Second, isolating systems from each other is absolutely critical. Third, redundancy is everything, for power, for networks, for your data. Fourth, remember that security is just as much physical as it is digital. And finally, none of it matters without people and machines watching everything all the time.
This incredible, complex, layered system is what's protecting your money right now, today. But it does leave us with one final thought. The attackers, the bad guys, they're constantly evolving their tactics, and technology is always changing. So you have to wonder, what will the bank fortress of tomorrow need to look like to stay one step ahead?